There have been a lot of questions about how to structure an algebraic proof, so I've decided to include this next question, which is exactly that. It's proving something algebraically. So this particular question says, if A, B, and C form an arithmetic sequence, show that B is equal to A plus C divided by 2. So in this particular one, the only thing we know about A, B, and C is that they form an arithmetic sequence. And with any proof, it's good to start with writing out what does this mean so that, I guess in algebra, so that we can then use it to derive this kind of thing. So, well, if A, B, and C form an arithmetic sequence, well, that means that they sit like this. We've got A, B, C, and so on, and that they must have some common difference of D. Okay, that we're adding to each term. So that means that B has to be A plus this common difference D, and C has to be A plus 2 lots of that common difference. And that kind of makes sense. So what we've done is we've got a couple of equations relating A, B, and C. The problem is that we've got this D term that we've introduced, which isn't in the result over here. But you know, that's okay. Hopefully we'll get it disappearing as we move forward. Now with any proof, at some point you've got to look at this guy and start on one side and work towards the other. I'm actually going to start on the right hand side and tweak that until I get to the B, the left hand side. So I'm going to start like this. I need to state what I'm doing, so I'm showing that B is equal to A plus C on 2. So let's take a little break in my working. The right hand side, I said I'm going to start with, is equal to this. Now each step from here, I'm going to be taking something from the previous line and tweaking it down, 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 down until I get to the B. So what I'm going to do is I'm going to make the substitutions that I have done up here. Now A is just A. I didn't really make a substitution for that, but I can make a substitution for C. C, we said, was equal to A plus 2D. Oh, sorry. That A is this A here, plus C needs to become A plus 2D. I'll rewrite that without the brackets. And tidying up, I get 2A plus 2D divided by 2. Now, if you know what you're doing, you can just go cancel, cancel, cancel with the 2's. I don't like to do that because strictly what we're doing is another step in between here. What we're doing is we're factorizing this top, taking the 2 out the front, and then we cancel like this. Okay, we can cancel because once we factorize, we've actually got 2 terms. One is here, and they're being multiplied together. We probably shouldn't cancel here. We should be careful with an addition or a subtraction sign involved. So here I have A plus D left. But if you remember from our substitution, we said that B was equal to A plus D. So A plus D can be rewritten as B, and that will complete our proof. Okay, I've started with this, and I've reworked it through this algebra to end up with B, which was on the left-hand side. And that has been proven. And we'll write Q, E, D.